Welcome back to more factoring. Now, if you thought the last section was awful, you're right, it's awful. So this one is going to seem like a nice, easy break in return. Let's take a look at difference of squares. So all factoring, remember, comes from people doing lots of distributive property questions and recognizing patterns and seeing what they get and then trying to work that backwards. So if you've done a lot of these questions, you will know if you take something like this, where I put an x here and an x here, and let's say I put the same number here, so 5 and 5, but on one of them I put a plus and on one of them I put a minus. When I go to distribute this, expand it out, this is x squared minus 5x plus 5x, and 5 times minus 5 is minus 25. The two like terms in the middle this time are weird because minus 5x plus 5x is nothing. So this is x squared minus 25. So this is a special kind of trinomial, which is really x squared plus 0 x's plus some number. And this winds up being very, very simple because 4 things altogether, 2 binomials, two brackets of 2 things each, wind up combining just to be 2 things, which is very, very simple. Now, in order to make this work, by the way, this is why this is called difference of squares. X squared is x times x, and 25 is 5 times 5. Difference is the fancy word for subtraction. So that's why that is difference of squares. In order to make this work and in order to make this easy, you have to keep a certain list of numbers in mind, which is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared. I'm going to keep going until I run out of screen. 9 squared, 10 squared, 11 squared, 12 squared. Okay, so this is 1, this is 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. When I was in grade 7, our teacher made the entire class memorize this list all the way up to 20 squared. And it seemed like a horrible thing at the time, but it has become a huge benefit to me doing these questions, because what happens is these numbers, they're called perfect squares. And there's a weird thing that happens in math problems, particularly in factoring problems, but all over the place, is if more than one of these numbers shows up in the same question side by side, it's a hint that something interesting is happening, and it's a hint that you can be sneaky and save a little bit of time. So let's just work through, and you'll find this compared to all the other factoring very, very easy, provided you have these numbers floating around in the back of your head. So x squared minus 36. And the way I do this is I just notice x squared is made up of x times x, and 36 is made up of 6 times 6, and there's a minus in the middle. And this, in terms of writing, will be very fast. One of the x's goes here, one of the x's goes here, one of the 6's goes here, one of the 6's goes here, one of these is a plus, one of these is a minus. Done. Okay. This one, 25, is 5 times 5. This one is a little bit trickier. It is the number 4 and the number x, so this is 2x times 2x. And remember, what goes through all of the factoring problems, homework lessons, everything is the more expanding and distributing you've done, the easier it is to spot this. There's a minus in the middle. And so this becomes 2 brackets. One of the 2x's goes here, one of the two x's goes here. 5, 5, 1 plus, 1 minus, done. Same thing. So this is 81 is 9 times 9. So this is 9x times 9x. This is 16 is 4 times 4. 4y times 4y. There's a minus in the middle. One 9x goes here. One 9x goes here. One 4y goes here. One 4y goes here. One of them is a plus. One of them is a minus. Also notice this habit is very, very helpful. If you're doing questions where you leave space, you know sort of what the answer is going to look like, and you leave blank room, and then you fill in the answers, but not necessarily in order, jumping around. It can make answering some rather difficult questions a lot easier because it allows you to sort of take things in smaller steps. Good. Okay. So this one is more confusing. 1 I get, that's 1 times 1. This is x squared times x squared. So it is something squared even though it doesn't wind up being a squared number, but I can still work this. Let's see, bracket, 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 x squared, 1, 1, plus, minus, and done. No, just kidding. If you're really paying attention, you'll notice, hold on, this is also something squared. That's x times x. And this is still something squared. It's 1 times 1. So this piece, one of the x's goes here. One of the x's goes here. One of the ones goes here. One here. Plus, minus. Oh, I'm sorry. That should, those should not be there. Much better. My bad. And this still stays in the front. Okay? And the question should be, what about this? So we have a rule for difference of squares. Difference means subtraction. Does the same rule work for sum of squares? And the answer, and you can think about it for a while for yourself, is just no. How did we come up with this rule? By doing lots of distributive property questions and noticing that this pattern, something plus something, the same something minus the same something, gave two terms with a minus sign in the middle. And in doing this, you have not come up with one which has a plus sign in it. So as far as our rules go, difference of squares is a rule, sum, adding, of squares is not a thing. Okay? All right. So this one seems at first to not work because this is not something squared. This is something cubed. But hold on. Both of them have an x, and also both of these are divisible by 9. So I can first do common factoring. And 36 divided by 9 is 4. And now it works. This is x times x. This is 2 times 2. 9x, first bracket. This happens a lot in factoring, where if you do, if you just pull something out in advance, it floats in front and it doesn't change anything. One of the x's here, one of the x's here, one of the 2's there, one of the 2's here, put a plus, put a minus, and there you go. So that's all we've got. So hopefully after the awful thing that was, let's try and have nice handwriting because this is a happy video. After these ugly ones, Hopefully after this was nice, this was easy, this was relaxing, and you can go work on that. If there's a topic you'd like me to cover in one of these videos, by all means, just leave a mention in the comments, and rewatch and pause as many times as you like. And we'll see you next time for more factoring, or maybe something a little bit more fun.